for another video. This one's going to be on dividing multi-digit numbers. Now, just like the NS2 videos on multiplication, we are going to be doing two separate videos with two separate types of algorithms. This one being the standard algorithm. Now, if we look at this number 624 divided by 4, just like multiplication is just a step above addition, it's repeated addition, division is just repeated subtraction. So as we work through this number, the question we're really trying to ask is, how many times can we subtract 4 from 624? That's what division is actually asking us. So when we look at this problem, and many of you have seen this algorithm before, but it's really important to make sure that we're understanding what it's trying to do. If I look at the first number, which is 600, the question is, what is the largest number of times that I can multiply 4 to get close to 600? Now I know that 400 is going to be very close to 600, so I'm going to do 100 here. So this is not a 1, this is a 100. So I take 100 times 4, and that gives me 4. Now, many times you will see someone draw a subtraction sign and a line, and they'll just do 6 minus 4. I do it a little bit different here. What I actually like to do is I like to add in all of the zeros across the row to give me 224 remaining left over. However, sometimes people will do, let me show you, they'll do 400 here, and then they'll simply do 200, and then they bring down the next digit, which is 22 tenths. That is fine as long as you are using the correct terminology in the method and saying that this is 220. Okay, so now once again we do the same process as before. The question is, if we're looking for 22 tens, what is going to be the closest multiple that we can get, which in this case is going to be 20. We do that by doing 5 tens up here times 4, which gives us 20. So once I have 20, I can subtract again, which gives me 2 tens left over, and then the final digit will be, ooh, that was not a great line, which is our 4 ones, which ends up being 24, and the largest multiple will be 6. So we have an answer of 156. We have no remainder, which means that 4 times 156 is equal to exactly 624. Now I mentioned before that I work through these problems a little bit different. So what I'm going to do is we're going to restart this problem, and I'm going to show you what I would do instead of adding the arrows. So once again, the first number is going to be the same. We're doing 100 because 400 is closest to 600 without going over. Now instead of just subtracting here, I'm going to add in my zeros, and I'm going to subtract, which is 224. Now the difference with before is that the 4 is down here, which can be a little confusing. That's why a lot of people do it the other way. So I look at only these first two places. The closest multiple I can get is 20. So I once again will do the same process as before, which subtracts to be 24, and we end up getting 6 ones left over. So we get the same number. Really the only difference in the methods is this spot right here. Some people do an arrow. I like zeros. Both are going to be fine. For the remainder of this video, I'm going to do the arrows because that is more common. As we work through this next problem, the only difference with this and what we did before is we now have the thousandths place. Now, normally we like to start with that first digit, but this time there is no multiple that is bigger than our, or is smaller than our 1,000. Therefore, we have to look at our 1,200 or 1,200s as our number. The closest that I can get to 1,200s is actually right on 1,200s, which is 3 times 400s, which gives us that right there. Now, this ends up being 0, which makes us bring down our 3 tens. The closest multiple to 3 is actually right on 3, so that is 3 times 1, 10. So I then subtract. Once again, I get a 0, and I bring down my last digit. Hopefully you can draw straighter lines than I can. And we end up getting, once again, another 1 in the ones place. And we get a remainder of 0. So what that means is that 3 times 411 is equal to 1,233, right on the nose. When we have more than a single digit divisor, it changes the problem a little bit. And this is where the other algorithm, which I show in the other video, can be very, very helpful. Now, I start with 12. And once again, I look at the first digit. There is no multiple that is going to be smaller than 12, so we can't do that. So we're going to look at the first 2 digits, which is 30. Now, the difference between this algorithm and the other one is I have to pick the largest possible number for this algorithm to work. So if I put up a 1 here, that would end up giving me a remainder here of 18. If this number is bigger than what you are starting with on your divisor, that means that you have to start over. Probably the biggest weakness of this method. But if I know that 1 doesn't work, 2 has to be the next multiple. So 2 tens times 12 gives me 24 tens. And now our remainder is just 6. So it's actually not that difficult at all from here. So I bring down, I have 60. And then this is the method that I like to do right away. I just simply do all of the multiples of the number that I'm working with. That's my first step. And because by doing this method, all I actually have to do is skip count as I work through the problem. And look at that, we ended up hitting it right on the nose. 12 times 5 is actually equal to 60. Therefore, 5 goes into my ones place. And once again, we're very lucky to have a remainder of 0. Therefore, 12 times 25 is equal to 300, right on the nose. Let's move to the toughest problem we have here. Now, once again, I'm going to do that method that I talked about right away. I'm going to do all the multiples of 13. So 13 times 1 is 13. 13 times 2 is 26. 13 times 3 is 39. 13 times 4 is 52. And 13 times 5 is 65. Now you could do this all the way up to 9 if you want, but I usually stop at 5 because sometimes I don't actually need all 9 multiples. So I go back to my problem. I can't find a multiple that is smaller than 3, so we have to look at 30 once again. I look at my list and I see 26 is a prime target here, so I put 2 into the hundreds place. And so then I get 26 hundreds. 30 hundreds minus 26 hundreds is 4 hundreds, and I bring down my next digit, which is 4 tenths. I go back to my list, and 52 is too big. 39 is just small enough. Therefore, my next one is 3 into the tens place. So I do 3 times 13, which gives me 39 tens. And I have 5 tens left over. I bring down my last digit, which is 2 ones. I go back to my list, and look at that, right on the nose, 52. So we get a 4 in my ones place. I get a remainder of 0. Therefore, 13 times 234 is exactly 3,042. So this is the video on the standard algorithms for division. If you have any questions, as always, make sure you let me know. If you don't score a 3 out of 4 or above, make sure you watch the next video.